Hey everyone, ready for another deep dive? Today we're looking into something really wild. It's a total scientific puzzle, and it's all about this weird spike in an element found in some really old ocean rocks.
Yeah, we're talking about a huge jump in beryllium-10. Scientists found it in these special rock formations deep in the Pacific Ocean called ferromanganese crusts.
Ferromanganese crust. Okay, so not exactly something that you'd find just walking around there, are they? What are those exactly?
Not your typical rocks, that's for sure. They form really slowly over millions and millions of years. Each layer kind of traps stuff from the water around it, like elements and other things floating in the sea.
So like little time capsules then, from way back when.
Exactly. And in these time capsules, scientists saw something super strange, this massive increase in beryllium-10. It peaked around 10.1 million years ago.
All right, I'm hooked. But what's the big deal about this beryllium-10? Why are we so focused on it?
Well, beryllium-10 is what we call a cosmogenic nuclide.
Cosmogenic nuclide. That sounds intense.
It basically means it's created when cosmic rays from space hit our atmosphere.
So like space dust constantly raining down on us.
You got it. And some of that space dust settles in the ocean, gets caught in those ferromanganese crusts as they grow. The cool thing is beryllium-10 is radioactive.
Radioactive, huh?
Meaning it decays at a specific rate, like a clock.
A built-in clock. So does that help scientists figure out how old things are?
You bet. It's super useful for dating ancient stuff. But that's also what makes this discovery so interesting. Instead of less beryllium-10 as you go further back in time, there's this sudden spike about 10 million years ago.
So more beryllium-10 than there should be.
Way more. A whopping 73% increase.
73%. All right, that's got to be from something big. What could cause that kind of a jump?
That's the million-dollar question. And it wasn't just in one spot. They found this spike in lots of crusts from all over the Pacific Ocean. This wasn't some small local thing. Something major happened. Something global.
Okay, now I really want to know what caused it.
Yeah.
What are the top theories so far?
Well, there are two main suspects. One here on Earth, and the other points to something happening out in space. Let's start with the Earth-bound possibilities. So one idea is that there were some big changes in Earth's ocean currents. Around 10 million years ago, like this super powerful current formed. It circles all the way around Antarctica. We call it the Antarctic Circumpolar Current, or ACC.
The ACC, okay, and how would that cause all that extra beryllium-10?
Well, picture the ocean as this giant conveyor belt, moving water and all sorts of stuff all over the place. The ACC is like the big boss of that system. It controls how things get moved around, including elements like our beryllium-10. So when it formed, it probably messed with how beryllium-10 was spread out, maybe concentrated in some spots, could explain that spike we see in the crusts.
Interesting. The ACC is a pretty good suspect then. What about other things here on Earth, like maybe a volcano erupting, a really big one?
Good question. Volcanoes definitely spew out a lot of stuff into the air and the oceans. But even though they can release some beryllium-10, it's probably not enough to cause a spike this big on a global scale. Plus, we haven't found any signs of any super eruptions around 10 million years ago. That could explain it.
Right, so volcanoes are out. What about Earth's magnetic field? That seems like it could affect how much radiation reaches us from space.
You're on the right track. Earth's magnetic field is like a giant shield, deflecting all those cosmic rays, the ones that make beryllium-10 in the first place. So if it got weaker, for some reason, more cosmic rays could get through, and bam, more beryllium-10.
Makes sense. Weaker magnetic field equals more beryllium-10. But
Yeah.
could that really cause such a huge increase like we see in those rocks?
That's the thing. Earth's magnetic field changes over time, but scientists think the changes back then, around 10 million years ago, they weren't big enough to create that massive spike.
Okay, so the earthly suspects aren't totally off the hook, but the evidence isn't really there. So let's look at space. What could have happened out there to bombard Earth with all that extra radiation?
Well, one possibility is a supernova.
A supernova.
It's a star basically dying, explodes in this massive burst of energy, including a ton of cosmic rays.
Whoa! So a dying star could shower Earth with enough radiation to cause that beryllium-10 spike.
It definitely could. A nearby supernova could explain it for sure, but there's a catch.
Oh, I knew it. What's the catch?
If there is a supernova that powerful, that close to Earth, it would have left other clues too. Maybe triggered extinctions or left behind certain isotopes in the geological record. But so far, scientists haven't found that evidence.
So not impossible, but a supernova seems a little less likely without any extra proof. What about that other space theory, the one you mentioned before, about our solar system passing through some kind of cloud?
Oh, yeah. That one's interesting, too. See, our solar system is always moving through the Milky Way galaxy.
Our whole solar system just cruising through space. Wild.
Right. And as it travels, it can run into these big patches of gas and dust called interstellar clouds.
Okay, and what happens if we hit one of those?
Think of it like this. The sun has this protective bubble around it called the heliosphere. It keeps out most of the cosmic rays. But if we pass through one of those clouds, it could squeeze that bubble.
Squeeze it.
Making it weaker. And then more cosmic rays could leak through, hitting Earth, and potentially causing a big jump in Beryllium-10 production.
Like squeezing a balloon. You make the skin thinner and more stuff can get through. Okay, so we've got that possible explanation with the ocean currents, and then these two spacey ones, the supernova and the interstellar cloud.
Yeah.
Where are scientists leaning right now? What seems most likely? So we've got that possible explanation with the ocean currents, and then these two spacey ones, the supernova and the interstellar cloud. Where are scientists leaning right now? What seems most likely?
That's the thing. It's still kind of mystery. The ocean current shift seems pretty likely. The one with the ACC forming, the timing fits. And it could explain why they found the spike in so many places. But that interstellar cloud idea, that's still out there too. We need more research to know for sure.
So the case is still open. But even without knowing for sure what caused it, this Beryllium-10 spike, it's still a pretty big deal, right? It's not every day scientists find evidence of something this crazy, happening millions of years ago.
You're telling me. It's a big deal for a few reasons. For one thing, it shows just how connected our planet is to space. We like to think of Earth as this self-contained thing. But this Beryllium-10 spike, it's a reminder that things happening way out there, in the cosmos, can directly affect us right here.
It's like the universe is saying, hey, what happens out there matters down here. You're not as separate as you think.
Exactly. The other thing is, this spike gives us a new marker in geological time.
Oh, right. Because Beryllium-10 acts like a clock.
Right. So this spike, it's like a super precise reference point, a timestamp almost. It helps scientists match up different geological records and understand Earth's history better.
Like finding a missing piece of a giant puzzle. So what happens now? What are scientists doing to solve this Beryllium-10 mystery?
Well, one thing is looking at deep-sea sediments. They build up a lot faster than those ferromanganese crusts. They're like a more detailed record of the past. By looking at the Beryllium-10 levels in those sediment cores, scientists might figure out exactly when the spike happened and how long it lasted.
Like zooming in on a specific part of Earth's history to see if there are clues we missed before?
You got it. They're also checking for signs of other cosmogenic nuclides, different ones.
So more space dust.
Well, yeah, different types of space dust, basically. Each
Yeah.
one forms from cosmic rays with different energies. So by studying the patterns of a bunch of different nuclides, scientists can get a better picture of what the cosmic ray environment was like way back then. And that might tell us more about what caused the spike.
It's like a whole team of space detectives working together to crack the case.
I like that. And it just goes to show how much we still don't know about our planet and its history. Every discovery opens up more questions and more possibilities.
This Beryllium-10 spike is a perfect example of how science is always pushing the limits of what we know and reminding us how much there still is to discover.
Couldn't have said it better myself. And it's that curiosity, that drive to explore the unknown, that makes science so awesome.
I'm definitely leaving this deep dive thinking differently about Earth and its connection to the cosmos. It's mind-blowing to think that something happening millions of light years away could have left its mark on our planet.
It really is. And who knows what other mysteries are out there, just waiting to be found right here in our cosmic backyard.
If you're as intrigued by this Beryllium-10 mystery as we are, head over to the show notes. You'll find more info there and links to the research. And hey, we'd love to hear from you. Share your thoughts and theories with us on social media.
Keep exploring, everyone. Keep asking those big questions and never lose that curiosity about the world around us.
And get ready for our next deep dive. We'll be looking at something completely different, but just as mind-blowing, I promise.